In this video, we're going to solve a radical equation, and how this one is different from the previous ones that you've seen is that this has two radicals in it. So we're going to have to repeat the process of getting rid of the radical twice for this one. So we're going to have to concentrate on one at a time. So the first thing we're going to do here is let's focus on getting rid of this radical right there first. Okay, so we're kind of pretending everything else doesn't have a radical, and we're trying to get the radical term alone. So I'm going to try to get this radical term alone and then remove the radical by squaring both sides. So that's my first process. So in order to get this square root by itself, I'm going to have to move over the second square root. I'm going to have to move over that one by subtracting. So when I do that, I have the square root of 3x minus 5 equals 2 minus the square root of x minus 1. Now the right-hand side of this is going to be a little bit messy for the time being, because our next step is going to be to square both sides, because we're trying to get rid of the radical on the left-hand square root. So if we square both sides, we have no option except to FOIL this out. Okay, so it is going to be a little bit of work here. So on the left-hand side, not too bad. We've got 3x minus 5 when we have the square root and we square. On this side, I'm going to write it out twice because I'm going to show you what I'm going to get when I FOIL it. So just be careful. You know how to FOIL. You know how to distribute this out. So do it the same exact way you normally would. So when I do the 2 times the 2, I get a 4. Not bad. Then when I do the 2 times the minus square root of x minus 1, I get minus 2 square roots of x minus 1. Then when I start distributing this, I get another one of those terms. And when I distribute this, okay, so just be careful here. I have a negative times a negative, so I have a plus. And square root of x minus 1 times itself is actually just x minus 1. I don't really need parentheses around that because I don't have to distribute a negative. If I did, I would be careful about parentheses. So this kind of looks like a mess. So we're going to clean this up a little bit before we do anything more. So my next step is just to work on the right-hand side. So I'm going to combine like terms. So these are like. I'm going to combine the 4 and the minus 1. Sorry. So I got a 3. So I have a 3, I have a plus x, and I have minus 4 square root of x minus 1. Okay, so next I'm going to now focus on getting this radical by itself. So I'm going to bring everything over to the other side. I'm going to bring over the 3, and I'm going to bring over the x at the same time. So I'm going to have 2x minus 8 equals negative 4 times square root of x minus 1. So I'm just going to add a slide here so I can keep going on the next page. Okay, so what we had here was 2x minus 8 equals negative 4. Okay, so now we're going to get rid of, so if negative 4 could divide into both of those on the left, I would divide it out. But since it doesn't, I'm going to keep it with that, and I'm going to keep it as part of what I'm squaring. I'm going to square both sides because I'm trying to remove that radical on the square root of x minus 1. On the right-hand side, again, the right-hand side is a little bit easier on this one because I get 16. And then, so that's negative 4 squared. So I'm squaring the negative 4, and then I'm going to square this, and that will give me just an x minus 1. I'll distribute that in a second, but I've got more work to do on the left because on the left I've got to FOIL that out. All right, it's getting better. We have all the radicals gone, so now we're just focusing on what we get. Do we have a linear or a quadratic when we're done with this? So let's see. Let's FOIL this out. We get 4x squared. I get a minus 16x on the outer, a minus 16x on the inner, and a plus 64 on the last. And here I have a 16x minus 16. So let's do a little bit more simplifying here. I'm combining like terms to get a minus 32x. I combine those. It's getting better. Oops. Okay. Minus 16. So now I'm going to, I realize that I have a quadratic here. So I'm going to have to bring this to this side by subtracting in this to this side by adding to get everything to one side. So we'll end up with a 4x squared of a minus 48x plus 80 equals 0. And I do see, so now I'm going to solve this by factoring. I do see a common 4, so I can divide out a 4. Since it's an equation, I can do it to both sides. I get x squared minus 12x plus 20 equals 0. Okay, and this one's nice and factorable. So let's see, I'm looking for numbers that multiply to 20 that combine to a negative 12. So it's going to be x and x minus 10 and minus 2, because that multiplies to a positive 20. And also combines to a negative 12. So when I set each one of those equal to 0, I get x equals 10 and I get x equals 2. So what you have to do on these ones, this is not an option, like an optional check. I have to check these in the original equation. Okay, so I've got to go back. This is because I turned a square root equation into a different type of equation to solve it, so I can get what are called these extraneous solutions. And so I've got to check back in the original to make sure they work. And if you do that, if you go plug in x equals 10 back into the original, you get something that's a false statement. So that one we have to reject. It's not valid. When you plug in 2 and you plug it back into the original equation, everywhere you see an x, this one does check. So this one is valid. So the only solution actually on this one I have is 2. So sometimes in this case they both work, sometimes neither one works, and sometimes one works. You don't really know before you get started. You just have to do the check. Okay, so I hope this helps you with solving the equations that have 2 radicals.